Hey, what's going on, folks? We're going to try to keep this video to 15 minutes and then I'll just make a few of them. Today we're going to cover chapter 7.2. We're talking the molar mass of a substance. And again, this is still one of those conversion factor things. All it is basically taking the idea of a group of something and then making it into either individual or pieces or things of that group, just to make the math easier as far as counting goes. So what we're going to do is we're going to say, all right, we have 9.45 moles of dinitrogen trioxide. So 9.45 moles of dinitrogen trioxide. So that would be, I think it's N2O3. And I skipped the chapter on nomenclature, but essentially dinitrogen, di means two. Tri means
three.
Obviously three. So dinitrogen trioxide is 2 N's and 3 O's. So here's what's going on. Here's how to do this problem. And I'm going to ask you to grab your periodic table because we're going to be using it a lot. First thing we need to do is, last time we calculated out those things called molar mass. And the way we do that is we say, okay, what is the molar mass of N? How many grams in 1 mole of N? And you use your periodic table to do that. And basically it's that small number at the very bottom of the thing. So here, you hold on to that. All right, what is nitrogen?
14.
14. So it's 14 grams for every mole, right? And that's specific to nitrogen. Now in this particular case, I'm going to multiply the whole thing times 2. Why would I do that?
Because there's 2 nitrogens.
2 nitrogens, exactly. Oxygen, what is that?
16.
16 grams per mole. And I should multiply that whole darn thing by 3. Cool. So that's equal to 28, and then 3 times 16. What is that equal to? Wait, I have it written on my notes, and I probably should be able to do it off the top of my head. It's 48. 48. So if I were to add this together, this gives me 76, right? So that's saying that for every 1 mole of N2O3, it will weigh out, or it will have a mass, not weigh, because weigh is different, but it will have a mass of 76 grams of N2O3. Cool? So that right there is that conversion factor that I was talking about, but that's specific to dinitrogen trioxide. So you start off with 9.45 moles of N2O3, and then we're going to multiply it by that fraction. Now that fraction basically says it's going to be this thing right here, but here's the question, is moles going to be on the bottom or is moles going to be on top? Is grams going to be on bottom or top? Which one do you think?
Moles is on the bottom because they cancel out.
Exactly. In order to cancel out the moles on top, because the moles are on top over here, we need this moles to be on the bottom. So I'm going to put 1 mole of dinitrogen trioxide, and on top is going to be 76 grams of the same stuff. The moles will cancel out with the moles, and then basically we just figure out, well, what's 9.45 times 76? Is your head in the way? I can't see. I got it.
718.2.
718.2, cool. All right. And if I were a real stickler about this, and actually to be honest with you, I am, I would say that's, in the way we have it written down, I would say it's 720 grams of N2O3. And the reason why I would round it, and why would I do that? Why do you think?
Because 0.2 grams doesn't matter?
No. Because sig figs. and you learn about sig figs way back when, yes, it's going to come and bite you back in the butt back again. And the reason being is because we only use 2 sig figs for this number and 2 sig figs for this number. So I could only justify my answer out to 2 significant figures. What I would do is, if the problem gave me 3 significant figures, I don't want to limit that down by using only 2 sig figs here. So instead of 16, I would use 15.9, because oxygen is 15.999, right? So that one can round off to be 16.0, and that has 3 sig figs. And then 14, what is nitrogen exactly?
14.007.
Oh, okay. All right, well, honestly, 14.0, 16.0. So this could be 178.2, but I would say it's just 178 because this original problem had 3 sig figs, and the new sig figs is going to be 718 grams. Does that make sense?
Yes.
Now, look at this. If this were 76 grams for every mole, how many grams would 10 moles be? 1 mole is 76 grams. 10 moles is what?
0.7 or point?
No, we would add a 0 to this. So it's 760 grams. Does that make sense? 10 moles, if 1 mole is 76 grams, 10 moles is 760 grams.
Yeah.
Right? And so this is 9.45, so we're just slightly under 760. And so reasonably that would make sense to me. Does that make sense?
Yeah.
All right. The book kind of glosses over this part right here. It says, hey, remember from 7.1 when we did this? You're so good at it now, you know, you can easily just make that 76. That's kind of why I went slowly through that problem with you, but that's basically what they're doing. Cool. All right, let's do one more, and then we'll stop the video and start up a new one. All right. So now we're going to go backwards. Now I'm going to say, hey, here's the number of grams of something. How many moles am I dealing with? And you would still use that same conversion factor. So let's try this one. We got iron 3 oxide. So oxide means O3. And iron Fe, you need 2 of them to balance that out. Fe2O3, I believe that's it, right. And they're giving us 92.2 grams of this stuff. So we're going to get really good at this. Go grab your periodic table. What is Fe?
56.
56. Wait, give me 3 sig figs. 56.9.
9. Or 55.9.
55.9. Okay. And I'm going to multiply that whole thing by what?
3. Or 2.
By 2. Cool.
Yes.
And oxygen. What is oxygen?
15.9.
Well, it's actually 15.99, so I can make it 16.0. Does that make sense?
Yeah.
And we're multiplying that by what?
3. Or 3.
3 times 3. All right, handy dandy calculator. What is 56.9 times 2? And what is 16 times 3? Is that like a 113.8?
Yeah, 113.8.
0.8. And then what is 16 times 3?
14. Or 48.
48. I can do 48.0. Okay, so add those together. 113 plus 48, and you get
161.8.
161.8. Cool. All right, so this gives us our conversion factor, and this number right here is the molar mass, which is telling you this is how many grams 1 mole of that junk would be. So if I had 1 mole of iron 3 oxide, it would give me 161 grams. So I'm going to put, actually, I'm going to say 162 grams because we're dealing with 3 sig figs here. So 162 grams for every mole of Fe2O3. Now, originally they gave me 92.2 grams. So this right here is just side work. This is like the stuff I do on the side of my paper. And then I say, okay, now I have this conversion factor. Let's attack the real problem. I have 92.2 grams of Fe2O3. I'm going to multiply it by that fraction. Here's my question to you. Do I have grams on the bottom or do I have moles on the bottom?
Grams on the bottom.
Okay. So you have 162 grams for every 1 mole of this stuff. Does that make sense? And technically I can put Fe2O3. Fe2O3. This grams of Fe2O3 and grams over here cancel out, and I'm left with 1 mole of that stuff as far as my units go. And then you just plug in the calculator. What is 92.2 divided by 162? 0.5691.
Yeah.
Okay.
Or if you 3 signifiers would be 0.569.
Okay, let me see. On my side, I got 0.570. And on their side, they got 0.578. Now, technically, with the significant figure game that we play here, it should all be the same answer. What I'm thinking in my head is I'm teaching you guys maybe, I don't know if I'm doing it the sloppy way. I'm a physicist and an engineer, but maybe they're carrying significant figures a little bit differently. But let's see. Let's try this again. Let's try, don't do 162, do 161.8. What is 92.2 divided by 161.8? It might change the answer just a little bit. Right here.
Okay.
Divide that number by that number.
No.
0.569.
The same.
Okay.
That's good.
All right. Well, riddle me this. I'm going to throw this out there to the other parents and other, people. Why is my answer different from the book in problem 7-7? Not 100% sure, but this is the answer that I got as far as how many moles of Fe2O3 I'm dealing with. And are you sure you got 59.9? So that's correct, yeah? I don't know. I feel like we're doing it correctly. Anyway, let's see what we got there.